Hello, everyone. I know it's been a long time, but we started with the basics of the graph. Okay, now I'm going to solve two questions related to graph, which are like important lead code questions. So you'll get a basic understanding of when to use BFS, how to use, what type of different questions could come. I could take two variations as of now, but I can give you some more questions in the description, and you can try and tell me like how it's working for you. Okay. Okay. So my first question, which I wanted to take today, is the rotten oranges. You might have heard of this or not, but there are similar questions like this which could ask in many interview questions, and I've literally seen it. Okay. So what does the question says? The question says that, okay, let me just share the question directly. Cool. Okay. So I could share this question directly. And the question says that you are given an M cross N grid where each cell can have one of the three values. What? 0 representing an empty cell, 1 representing a fresh orange, or 2 representing a rotten orange. Okay. Now, every minute, any fresh orange that is four directionally adjacent to a rotten orange becomes rotten. Okay. So we have four directions to move: up, left, down, and right. Okay. Any fresh orange which is in any ways four directionally adjacent to any rotten orange, it becomes rotten in 1 minute. We need to return minimum number of minutes that must elapse until no cell has a fresh orange. And if this is impossible, return -1. Okay, so let's say this is the only rotten orange we have. Okay, so in 1 minute, we could see that this two have become rotten because this two are adjacent to this. Now, with this, we can do this, and with this, we can do this, or with this only, we can do both of this. Okay, fine. Then, no need of this rotten orange to spend the time on because this can rot this, or this. Okay, if this is the first row, then first row, first column, 0th row, 0th column, and second row, 0th, second row, 0th column. These are the three possible ways, but this is empty. This is already rotten by the above orange, and this is also already rotten. So, no need to waste time on this. So now these two are rotten. So this can rot this and this can rot this. So actually it took 1, 2, 3, and 4 minutes. 4 minutes to rot full of this. And if there are no possible ways we can make it fully rotted, we should return -1. There are chances, okay? Like this cell. Let's try this 211 011 101. Okay, so I can go again to this. We have 211 011 101, 011, and 101. Okay, so we have 3 cross 3 grid. Okay, 211 011 101. 0 means empty cells, 1 means fresh cell, and 2 means rotten cell. Okay, so this is the rotten. Now this will rot after 1 minute. It will rot this cell. Okay, so it will rot this cell in 1 minute. Now this will rot this too. Okay, so in 2 minutes, this too will be rotted. Now this can rot this. It's at third minute, and at fourth minute, it can rot this, but still we have one fresh left. So it's not like all fresh have been discarded or it's been rotten. We have still one fresh. So if this is not possible, it's not possible with this single rotten orange to make all fresh oranges to be rotten. So we'll return -1 in this case. Cool. Okay, fine. So now how we will do it? Uh, okay. So what you have to do? First thing, you will apply BFS or DFS. BFS. Why BFS? Because with each cell, we need to go to all of its child and make it rotten. With one rotten orange, we need to go to all of its children and make them rotten at the same time, at the same minute. So we will use BFS for this case. Now, to check if all fresh oranges have been rotten, we'll keep one variable called fresh, and that should be 0 at the end. Then only we'll return the answer, else we'll return -1. That's simple. Now, as we have seen this example, right? the example here that this cell of which first row 0th column, no need of spending time on this because already it's rotten. So we will consider the minute only if a particular rotten orange can make at least one fresh orange to rotten. If any orange can convert at least one orange, at least one fresh to rotten, then only we will consider that minute. So we'll do minute plus plus only if one rotten orange makes at least one fresh orange as rotten. Then only we'll do this. Otherwise, we'll not do this. Then only we'll consider this minutes of plus plus. Cool? Okay, so these are the three base conditions. Now, at the time 0 or at minute 0, we'll push not just a single rotten orange, we'll push all rotten oranges. Okay, what we will do? We'll push all rotten oranges so that all will be considered in a single minute. So let's say you have this thing. Okay, you have 2 1 1 0 1 1 1 0 2. Okay, so you have this two rotten oranges at time 0. You'll push both of this. Why? Because then at minute 1, this rotten orange will rot this orange and this rotten orange will rot this orange. So at minute 1 only, both this are rotten. And now at minute 2, this rotten orange will rot this 2. Again, because this is not, this is fresh, will return -1. But still, let's say if this is 0, then in 2 minutes, our answer should be 2 minutes. Otherwise, consider the same case. Okay. Consider the same scenario of 2 1 1 0 1 1 0 0 2. Okay, consider the same case. And if you'll rot this at first minute, okay, this will be rotten at first minute, and you haven't pushed this. Okay, then at minute 1, this will be rotted. This is already rot. This will be rotted. Okay, now this will be pushed out of the queue. So at minute 2, this will be rotted. And then at minute 3, this 2 will be rotted. So total time took will be 3 minutes in this case, if you go line by line. But for all the rotten oranges in the queue, we have to do it in single minutes only. Okay, fine. Because the question says that every minute, any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Okay, cool. Fine. Then let's solve this question directly over here. So we'll push all the rotten oranges first. Okay. I have int n as grid dot size and m as row. Grid 0 dot size. Columns. Okay. We'll have a queue which will be storing the pair. Okay. So for int I0, I less than n, I plus plus. For int j is equal to 0, j less than m, j plus plus. If your grid ij is equal to 2, that means it's rotten, then we will push what? This pair of I comma j. And I have one variable also here, int fresh is 0. Okay. So else if my grid ij is 1, I'll do fresh counts. Okay, I'll increase my fresh counts. For this grid type of questions, you need to have a directions array and a safe array. Okay, so we'll have one vector of pair of int comma int directions, which is 0 minus 1 minus 1 0 0 1 1 0 for 4 directions. And we will have bool safe, which says int I, int j, vector of int ampersand grid, int n, int m. Okay, so if I greater than equal to 0 or if I less than 0 or I is greater than equal to n, or j less than 0, or j greater than equal to m, or grid ij is not equal to 1. We need to have 1. We need fresh orange cells only. So if it is not equal to 1, in all this case we will return false. Otherwise we will return true. Cool. Now we have all these things in the queue. Okay. Now what we'll do? Now while not queue dot empty. Now we won't need visited array. Why? Because the moment I'm changing my fresh orange to rotten orange, in the grid itself, I will make that value as 2 instead of 1. So I'll remove the 1 out of there and make it 2. So next time I cannot visit any 2 cells. I'll visit only 1 cells, as you know, right? So every time I'm coming and going out, I'm making that cell value change. So that's why I won't need visited array. Now, I hope you got this point now. Cool. Now, in size is equal to q dot size. Why I'm taking q dot size? Because I want to consider all the oranges which are currently in my queue to be processed in a single minute. In a single minute. Okay. So, what I'll do is for int I0, I less than size, I plus plus. Okay. I'll traverse all the rotten oranges currently in my queue. I'll make one flag as 1. If any one rotten orange could make any fresh orange to rotten, that means I'm successful and I can increase my minute at that time. So I'll have one int minutes, which is 0 initially. Okay, and initially my flag is 0. Okay, now what I'll do, I'll take my int row as q dot front dot first and int column as q dot front dot second, and I'll pop that out. Okay. Now I'll go in all directions. So for auto ampersand element and directions, your x will be what? This row plus element dot first, and y will be column plus element dot second. If safe, this xy grid n and m. If it's a safe, okay. If it's 1, then I'll make this grid of xy as 2 now. Okay. I'll push this in my queue now. Now I'm pushing it, but I'll go until the initial size only. So don't mix that up. Okay. And another thing, I'll make my flag as 1. Now, after completing this for loop of size, means after going through all rotten oranges at single minute, if my flag is 1, I'll increase my minutes plus plus. And of course, what you need to do? You need to do fresh minus minus. Anytime you receive safe, you'll reduce your fresh orange count. Cool. And now, if fresh is 0, we'll return what? Minutes. Else we'll return what? Minus 1. I hope you got this question very correctly now. Okay. Super question to learn about BFS and its approach and its applications also. Okay. One thing to make sure here is why am I taking this size? Because as I said, I need to consider all the oranges at the single minute which can rot other orange. Example, I've already shown. Okay. Let's move to next question, which is uh, this question. Let me share this tab. Okay. So the question says you are given an M cross n matrix board containing letters X and O. Capture regions that are surrounded. We need to capture regions that are surrounded. Now, what does it mean by surrounded? So, connect means a cell is connected to adjacent cells horizontally or vertically. Region means to form a region, connect every O cell. So, here, this is one region, this is another region. There are two regions after connecting every O cell. Okay, now surround means a region is surrounded if none of the O cells in that region are on the edge of the board. Such regions are completely enclosed by X cells. Okay, so let's say this middle one, this is not on the edge of the board, and it is completely surrounded by X, as you can see. Okay, from all four directions. So we need to capture such surrounded region, and for those region we need to replace all O's with X. I need to replace for all the surrounded region O's with X, but for the edge I cannot do this. Now give me okay, let me share this tab. Okay, now tell me that, okay, so this is our second question, which is surrounded region. Okay, now let's say you have this example. This is X, 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 O, 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 X, 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 O, 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 X, X. Okay, so now how many regions you have? You only have one region. This is because it is connected vertically and horizontally. So this full is one region only. Okay, now edge cells are not fully surrounded by X. You could see only this side, and this side are surrounded by X, but not on the bottom side. So that's why we will not replace any O with X because this is not surrounded region. Okay. Now consider another example. It's hard to explain this question. This is literally a hard question to understand. Okay. Now let's say use this X, O, X, 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 O, O, X, 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 O, O. Any cells? No, no cells. Okay. Uh, let's say this is X. Okay, and this is O. This is O. So that means now you have how many surrounded regions? Three surrounded regions. Three connected regions. But out of this three connected region, only one surrounded region. So you just make this 2 as X and remain this O as O and return this answer. So if you don't have to return, you have to change the grid given to you only. Cool. So that means the important conclusion we made out is any O's, any O on boundary can make connection, any O on boundary which can make connection will not be surrounded region. Rest can be. So that means, see this first example. This O are boundary. This O will not make any O as connected, but this O will make this O as connected, and then this will make this connected, and then this will make this connected. And then this, of course, it's on boundary only. So this full became one connected region and it is on the edge. Okay. So that means this full cannot be surrounded. But the example which is given here, okay, has three regions in three O's in between and one only on the boundary. So that one O will remain as it is and three changed. Okay. Now what do we apply? DFS or BFS? The question again is. Okay, BFS mostly will apply when we want to do something like minutes question, like timing question we need to find out, or how many we can change from current set. All the next sets we have to change. TFS will apply when we have to go to the depth and just change one. Okay, so here what we have to do is for all edge O, any O connected with edge O, any O connected with edge O will change it to some other letter, let's say A. Okay, that means all those O's or all those connected regions are only connected, not surrounded. Okay, and that means we have converted them to A now. Now what we will do, all A's will become O, and so first all O which are left, which are not connected with the edge of the O, that will still remain O in your matrix or grid, that we will make it X. And then all A's, we will make them back to O's. Okay, because those are originally O's only. But just to not confuse, we make it A and then we make all O's as X. We cannot directly convert all O to X. We have to remove all boundary O's and boundary O's which are connected to another O's also. So that's why we did DFS. And by doing DFS, with all O which are coming on the boundary, we will apply DFS and we'll go and check whether any O are connected to this O. If we'll found, then we'll make them A and we'll make the current O also as A. Okay. Again, we are changing the value in the grid only, so we won't need the visited. Okay. Fine. Let's solve this question now. Okay. Again, there are four directions to visit. I can take this from here only. Okay. Four directions to visit: I less than 0, greater than equal to n, j less than 0, j greater than equal to m. And we will visit only O cells. So this is character grid. And if grid ij is not equal to O, will return false. It should be O only because we are moving to O cells only. Now I have one DFS wherein I will pass the start and end node wherever I'm coming as O. Okay. I'll have one board or grid and n in m. What you'll do? You'll first make this O as A. Okay, so I'll make board of ij as A because it's already O. Then only we entered the DFS. Now I'll go to all its child. So for auto ampersand element in directions, your child x will be I plus element dot first and y is j plus element dot second. Now if safe, what? Xy. This board n and m. If it's a safe, we will again do DFS from this x and y. So all connected depths will take into the consideration. I hope you're getting my points over here. Okay. Okay. Done. This will change. Now what we have to do is n is our board dot size, m is board 0 dot size. For int I0, I less than n, I plus plus. For int J0, J less than m, J plus plus. Now, if your board Ij is equal to O, and if your board Ij is O, and that should be in the edge. So, if I is equal to 0 or J is equal to 0 or I is equal to n minus 1 or J is equal to m minus 1. So, this is your border. Then only you will perform DFS for this Ij board and n. Now, as I have discussed, all O's which are not surrounded will be converted to A. So, rest all O's we can change to first X and then that all A's to O's. Okay. So, now for int I0, I less than n, I plus plus. Again, J0, J less than m, J plus plus. If board Ij is equal to O, we'll change it to X. And again, if it is equal to A, we'll change it to O. You can do it in the same loop also because anyways, fine. And we don't have to return. We just have to make the same board converted. So I hope with both of these questions, you got the DFS and BFS approach very clearly. Okay. Cool. So next time I'm going to take some another topic which could be mainly related to the cycle detection and all. Okay. It might take some time because my exams are coming for the masters, but still I'll try to make it as soon as I can. Stay tuned, stay safe until then, and I'll put these questions in the description. Do solve it, people. Okay. Do like, share, and subscribe if you've learned a lot out of this. Bye bye.